In this video, we look at the effects of soil pH on the cation exchange capacity. The cation exchange capacity of a soil depends on the pH. At low pH, that's acidic soils, the cation exchange capacity decreases. That's because at low pH, hydrogen ions displace other exchangeable ions from the soil. So here we have Mg2+, which is an essential plant nutrient, and that's in the soil. And these hydrogen ions here are displacing the magnesium ions from the soil, and then the magnesium ions are going into solution. So the nutrients, that's the Mg2+, they are leached from the soil and they're unavailable to be taken up by plants. At high pH, the cation exchange capacity increases. At high pH, that's basic soils, the OH negative ions remove the H plus ions from the hydroxide groups in the clay. So in this equation, we have the hydroxide ions, OH negative, they're removing a hydrogen ion from the clay, and that gives us a negative charge on the clay and a molecule of water produced. The negative charge is increased, which increases the cation exchange capacity of the soil. Next, we look at the effect of soil pH on the availability of plant nutrients. So acidic soils have high concentrations of Al3+ and Fe3+ ions. Aluminium and iron ions are only available at low pH. Because of the high charge density of the Al3+ and the Fe3+ ion, they form weakly acidic solutions. At high pH, the equilibrium in these two reactions here shifts to the right as the H plus ions are removed from solution by the OH negative ions in this equation here. H plus ions react with OH negative ions to form a molecule of water. At high pH, the insoluble hydroxides are produced. The Al3+ and Fe3+ ions are no longer available to plants. So here we have the Al3+ ion reacting with the hydroxide ion to form the insoluble aluminium hydroxide, and here's the Fe3+ reacting with OH negative to form the insoluble iron hydroxide. And finally, the Al3+ ions at low pH also remove phosphate ions. So here we have the aluminium ions reacting with the phosphate ions to form insoluble aluminium phosphate. Next, we look at phosphate ions. So phosphate ions are available in weakly acidic soil. Plants absorb inorganic phosphorus as H2PO4 negative, which is present in weakly acidic soil. These two equations here show you how the H2PO4 negative is produced, and that then is absorbed by the plants. Phosphate is removed at low pH as insoluble aluminium phosphate. And that's the equation that we just looked at. That's Al3+ plus PO4 negative forms the insoluble aluminium phosphate. At higher pH, phosphate is removed as insoluble calcium phosphate. So here we have the Ca2+ ion reacting with the phosphate ion to form the insoluble calcium phosphate. Next, we look at calcium and magnesium. So calcium and magnesium are unavailable at high pH. In acidic soil, magnesium carbonate and calcium carbonate are released as soluble Ca2+ and Mg2+ ions. And here are the two equations. We have calcium carbonate reacting with a H plus ion to form those Ca2+ ions, and here we have magnesium carbonate reacting with the hydrogen ions to form the Mg2+ ion. And finally, we look at copper and zinc. Copper and zinc are only available at intermediate pH. These ions are displaced by H plus ions at low pH and form insoluble hydroxide at high pH. So here we have the reaction of zinc ions with hydroxide ions to form the insoluble zinc hydroxide.